Welcome to Arista Cloudvision Overview. This module is divided into 4 sections: Cloudvision installation, device registration, device monitoring, and device provisioning. Let's move into section 1, Cloudvision installation. In this section, we will walk through a 3-node Cloudvision deployment with high availability configured. To perform the installation, you will need a hypervisor ESXi 5.5 or greater, or Red Hat Linux 6.5 to 7 versions, and the CVP appliance downloaded from Arista website. Given here are the system requirements to run a single Cloudvision virtual machine. So, you will need 3 times the resources for a 3-node deployment. Open the hypervisor console. In this demo, I will be using ESXi 6.7. To create a VM from the OVA image, click the Create a VM button and then select the second option to import the OVA. Select the OVA from the stored file location. Select the data store from your options. Select the VM network. While the VM creation takes place in the background, repeat this process for creating the other 2 VMs. Once the VM creation has been completed, launch the console of the primary node to start the configuration. As the first step, enter the default username, which is cvpadmin, and set a new password. Enter the letter M to proceed with the multi-node configuration. You will be prompted for entering the DNS server address, NTP server address. I will keep the other values as default during this installation. At the node configuration, you will have to enter the host name, IP address, and the default gateway. Repeat this process for the secondary and tertiary nodes. After After configuring the secondary and tertiary nodes, you will get a yellow colored message saying not to apply changes until you see the given message on the primary node. Navigate to the primary node and enter the letter A to apply settings. Wait till you get the message saying waiting for other nodes to send their host names and IP. Apply settings on the other two nodes. You will be prompted for primary node's password. After the installation, you will be able to access the Cloudvision console from any of the IP addresses that you have configured on the nodes. Enter the default web console username and password, which is cvp-admin. I will go ahead and fill out the new passwords, cluster details, and personal information as required. After entering the details, you will be able to access Cloudvision with the newly configured username and passwords. Welcome to the second section, Device Registration. In this section, we will be adding an Arista device to the Cloudvision console. You will need terminal access to the device that needs to be registered. In here, I have a party session established to an Arista data center switch, which is on the same network as our Cloudvision nodes. As the first configuration, enable LLDP on the switch by the LLDP run command so it reports the non-Arista neighbors to the Cloudvision servers. This will help in establishing a topology wheel. Then set the NTP server address to enable real-time telemetry. Configure sFlow so you can get the traffic flow details. Management API configuration will enable you in device provisioning. If you have a secret password, please set it to the same as Cloudvision password. After the switch configuration, go to the Cloudvision console's device page and then enter the IP address of the device that you want to register and click Onboard. You will be able to see the progress on the same page. Once the device has been added, you will be able to view the device on the inventory page. Let's try adding another switch and close out this module. As you can see, both switches have been added to the inventory. Welcome to Section 3, Device Monitoring. We will start off with the topology view. You can access the topology view via the button on the upper tab. Once you expand the data center and the rack view, you will see a complete topology on how the Arista switches are connected to each other and the downstream and upstream devices. The non-Arista devices are detected through LLDP. LLDP has to be enabled from the switcher's side and the other device's side. Once you click on a specific device, you will be able to see all the links executed from that device to other devices. Once you click on Device Overview, you will be presented with various metrics on the device. We will go through them one by one. On the first page, you can find system details, system status, and the interface counts, which shows you some general metrics. On the next section, which is the system, you can find details such as the changes occurred in firmware and software versions and the streaming metrics from the telemetry status section. Under the processor subsection, memory and CPU utilization as well as the ongoing processes can be seen, which helps in understanding the resource load on the devices. In next subsections, you can see the storage browser, log message database, hardware capacity, which includes the route and address utilization, running configuration, hardware details with the physical components listed, configuration snapshot details, and bug exposures. Below the bug exposure section, environment shows the details regarding the temperature levels, fan speeds, and power information. Switching section displays the layer 2 metrics such as ARP table, MAC address table, MLAG, and VXLAN details. Under routing, it shows the routing tables, BGP, IGMP information, and the segmentation details. Under traffic flows, numerous details can be obtained regarding the data gathered through S-Flow. We will revisit this section in upcoming modules. Under 802.1x section, you will get the port-based network access control information, and in the interfaces section, it will show the interface status of all virtual and physical interfaces available on the switch. Now let's move into the custom dashboards section. Let's say we need to create a dashboard with the details of switch 1 populated into it. To start the custom dashboard creation, click the new dashboard button. Let's give it a name as switch 1 details. And then let's try out some graph and table types. First, I select the horizon graph option. Then select the wave type as multiple metric for one source. And then select the device. Next, you can select the metric types that you need to monitor. I will select some device details, temperature, and memory utilization details. Now let's try creating a table. For this, I will select the interface counts metric. As the both switches has been selected, I will filter out only the switch 1. Let's also add the switching metrics. Let's also create a top K chart to display the most utilized interfaces. As you can see, we have successfully created a custom dashboard with switch 1's details populated in it. Traffic flows is the last submodule of this section. This shows the flow of traffic which occurs through the Arista device. In this graph, it shows the hosts with the most traffic flows sorted maximum to minimum. If we go into the highest communicating device, which is in pink, we can see which switches has direct connection to it and the total flow records regarding it. In this table, you can view all the individual data flows which is originated from the source. The details include source and destination IP addresses and ports, the protocol, and the ingress and egress interfaces. If we click the View in Topology button, we will be taken to the Topology View page, which will show the traffic flow path visualized. If we click on a specific traffic flow, it will show us the path in which the data packets were exchanged. We can filter the traffic flow data by source and destination host IPs, port numbers, protocols, users, and VRFs. Welcome to the fourth and final module, Device Provisioning. In this section, we will see how to push new configurations and images into the managed devices. Once you land on the provisioning page, there will be a table with a tenant and some entities under it. In my case, I have two entities, undefined and EGL DC. The tenant and the two entities are called containers. We will have a more clear look by navigating into the tree structure. As you can see, the tenant container is the parent to undefined and EGL DC containers, and the two switches that we have added are children of the EGL DC container. The container holds the configuration, also known as configlets and images on it, and it inherits to the same to its children. Let's see how to add a new configuration into the EGL DC container. Navigate to the Configlets section, and then you will see the currently defined configlets. Click the Add button and then Configlets. In my scenario, I need to create a local user named Nilanka in the two switches under EGL DC container. To do this, a name should be given and the CLI command to add a new user should be entered. After entering the command, click Save. To add the configlet to the container, right-click on the container and then Manage, then Configlet. Select the configlet which needs to be added and click Update. To push the configlet, you need to validate it on both switches. Right-click on a switch and then go to Manage, then Configlet. Untick the Reconcile configlets if there are any. We will look into those in a few moments. After you click Validate, you will be shown a comparison of the designed configuration and the running configuration. The configuration we added has only few lines, unlike the running config. To add the running config to designed config, click the Reconcile button and then it will fill in the gaps for us. After reconciling, click Save. Do the same for switch 2. After clicking Save, a task will be created. Go into the Tasks page. At the Tasks page, select the Update Config Tasks and click the Create Change Control button. In the Change Control page, click on Review and Approve to verify the configuration change for one last time. Click Approve and Execute to push the configuration into the switches. Image management is very similar to the earlier section. In the image management page, you will see the current switch images that are uploaded. You can upload switch images in order to update the switches. To add a switch image into the container, right-click, Manage, and then Image Bundle. You can select the required switch image and click Update, and then the image will be pushed automatically into the switches.